Welcome to the final unit of this chapter, rational equations. There are going to be two different methods we talk about on this one, cross-multiplying and multiplying both sides by the least common denominator. If you are going to cross-multiply, you must have two fractions set equal to each other with no addition or subtraction in between. Whereas when you multiply by the least common denominator, you'll notice that you have more than just two fractions. In fact, this one happens to have three. So if you have more than two fractions and they're not just equal to each other, then you have to use multiplying by the LCD. You can use the LCD for any problem. Cross-multiplying is the one that just only works for certain ones. So with that being said, I'm going to start with the least common denominator. All you do is simply look at all three of your denominators and find something that they can all multiply to get to. So in this case, 3 already goes into 6. And then the other denominator is an n. So my least common denominator, actually I'm going to write it in the other corner, is going to be 6n. Then you just multiply by 6n on all of the fractions. But we're really multiplying by like 6n over 1. Since I have an equation now, I'm allowed to just basically multiply the numerators by 6n. So this gives me 24n over 3 minus 7 times 6 is 42, n over n equals 6n over 6. The whole idea here is that if you have picked your LCD correctly, then 24n divided by 3 turns into 8n. 42n divided by n turns into 42. And 6n divided by 6 turns into n. And you just have a regular algebraic equation left to solve. I would need to subtract 8n to the other side. 1n minus 8n is negative 7n. And that still equals negative 42. So I simply divide by negative 7. My answer is 6. And I am done. The other alternative to this that really does the same thing is trying to get them all to have a least common denominator instead. So that is method 1. It is super simple. There are some steps, though, that you can save yourself a little bit of work. And that's what I'm going to basically explain on the next one. So if I can get all the denominators to be the same, then basically what happens is, let's say I had x over 3 plus 2 thirds equals 7 thirds. Well, x would have to be 5 because 5 thirds plus 2 thirds equals 7 thirds. So essentially, once the number on the bottom is the same, you're really only focused on the top part right here. X plus 2 equals 7. And you can solve that equation from there. That is what we are going to do on the next one. So it's still kind of the same idea of using the least common denominator, but in a slightly different way. For this next one, I have k and 2 as my denominators. So it's a little simpler. My least common denominator is going to be 2k. So the first fraction needs to get multiplied by 2. So now it has 2k on the denominator. The second one needs the k. And the third one also needs the 2. So essentially, I have 6 over 2k minus k over 2k equals 24 over 2k. And once I have those all the same, it's kind of like I'm multiplying the whole thing times 2k, because then they all will cancel out. and I just have 6 minus k equals 24. So I solve by subtracting the 6. I know there's a minus over there, but it's not on the 6. It's in between the 6 and the k. Negative k equals 18, or divide by negative 1, k equals negative 18. Most people prefer that method because it just saves you a little bit of simplifying work later, and it keeps the numbers a little smaller in the first place. Okay, we're going to do 2 more of this style, and then we'll talk about cross multiplying. All right, so on this next one, I'm going to go ahead and simplify one thing first, and that is this first denominator. If I take out the 3, I have w minus 1 left, which helps me because now I know that w minus 1 has to be part of my least common denominator. The only thing that's a little tricky about this one is that for my least common denominator, the number out front is not going to be 3 because of this one over here. It actually has to be 9. Then I just decide, what do all the denominators need in order to all become 9w minus 1? The first one already has the w minus 1 and a 3, so it just needs to get multiplied by 3 to become 9w minus 1. This gives me 9w minus 1 on the bottom, and 3 times 13 is 39 on the top. The next fraction needs the 9 out front, so I'm going to multiply it by 9, which gives me 9 over 9w minus 1. And the third fraction needs the w minus 1. When I go to multiply out the top part, though, this is going to turn into w squared minus 1w. And then the bottom part is again 9w minus 1. Now that they all have the same denominator, that part can be sort of canceled out because I'm really just worried about making the numerators equal out. 39 minus 9 is 30 equals w squared minus 1w. Whenever you have a w squared or an x squared or a y squared in your equation, you have to factor to solve it. When you factor to solve, you need everything on the same side. So I'm going to go ahead and subtract the 30 over to this side, which makes it 0 on the other side. And the two numbers that multiply to negative 30 and add to negative 1 are negative 6 and positive 5. Then I set each one equal to 0. I add the 6, w equals 6. I subtract the 5, w equals negative 5. And those are my 2 answers this time. Remember that if at any point your variable ends up being squared, because of that power 2, you get 2 answers every time. All right, last least common denominator example before we talk about cross multiplying. There is one number in the middle on this one that does not have a fraction, so we're going to go ahead and give it a denominator of 1, just so it looks like it is in the same format as the others. The other denominator I need to adjust a little bit is the last one. P squared minus 4 is the same thing as p plus 2, p minus 2. This helps me because now I can see that the p minus 2 part matches in both the first and the last fractions. So my least common denominator is going to be p plus 2, p minus 2. So the first fraction needs the p plus 2. the second fraction only has a 1 on the bottom, so it actually needs both of them. And the third fraction has both already, so it doesn't need a thing. This is going to give me p squared plus 2p over p plus 2, p minus 2. And I forgot to write it down here earlier. When I did it to the top of this fraction, I should have also written it on the bottom. And then instead of writing p plus 2, p minus 2, because I know that I need to multiply this out, I'm going to go ahead and change it back to p squared minus 4. Because if I knew that that was the factored version, it really means that these two are the same thing and they are interchangeable. To find the least common denominator, I just needed the factored form. So instead of writing p plus 2, p minus 2, I'm writing p squared minus 4 because they are the same thing. And then the other side didn't change, so it's still 8, p plus 2, p minus 2. As you can see, all of my denominators are the same, so I don't need them anymore. And I'm really just working with this top equation, which is p squared plus 2p. And then I'm going to go ahead and multiply by 2, which gives me 2p squared minus 8 equals 8. Because I have a p squared in this problem, I'm going to get everything on the same side. So I'm going to go ahead and subtract that 8 to the other side. P squared plus 2p squared is 3p squared. 2p, and then the negative 8s add to negative 16. Now, when you have a number in front and you're trying to factor, you have to multiply it by the last one. 3 times negative 16 is negative 48. I'm looking for two numbers that multiply to negative 48 and add to 2, which is going to be negative 6 times 8. But you don't go straight to the parentheses. You keep the 3p squared and the minus 16. But instead of writing 2p in the middle, you're going to write negative 6p and 8p using these two numbers. And then you can split that in the middle. You can take out 3 and p on the first one, leaving you with p minus 2. You can divide the other two by 8, leaving you with, what do you know? P minus 2. So your factors are 3p plus 8 and p minus 2 equals 0. Then I set each one equal to 0. The second one's going to give me an answer of 2, which is easy enough. But the first one is going to be 3p equals negative 8. Then you divide by 3. So negative 8 thirds and 2 are my answers. If you get two answers, make sure that they don't turn either of the denominators into 0. Because as we talked about on rational graphs, that's an issue. Since 2 minus 2 will be 0, it doesn't work in this factor right here. So we're not going to be able to use that one as an actual answer. It's just negative 8 thirds. So extraneous solutions do exist in rational functions. 2 doesn't work because it makes the denominator equal 0, and we cannot divide by 0 in math. All right, let's move on to some cross multiplying. Most people prefer these. Cross multiplying is where we use the fact that if two fractions are equal, then they're cross products. So 4 times x minus 6 and 7 times x must be equal. Just be careful because when you do 4 times x minus 6, it needs to multiply to both of them. So not 4x minus 6, but 4x minus 4 times 6, which is 24, equals 7 times x is 7x. To solve, I subtract that 4x over to the right side. Negative 24 equals 3x is what I'm left with. And I will divide by 3 on both sides to get a final answer of negative 8. And it's pretty much the same idea on the rest of them on this side. Sometimes it's going to give you an r squared, and you're going to have to factor it, though, or an x squared or a k squared, whatever it might be. I said r squared because this one happens to be r squared as the first diagonal. Equals 4 times r minus 1 is 4r minus 4. Then, because there is an r squared, you have to subtract the 4r and add the 4 to the other side. Then we're looking for two numbers that multiply to 4 and add to negative 4, which is negative 2 and negative 2. So r equals 2. It did not give me two separate answers this time. It gave me the same answer twice. That's fine. You don't have to say that. And that's it. Okay, we've got 3 cross multiplying we're going to try, but basically that's the gist of all of them. Just be careful because sometimes when you go to cross multiply, the ease of some problem gets you a little stuck on others. For example, this one. I have to actually multiply m plus 3 times m minus 2. And that will equal 8 times 3, which is 24. But when I multiply that out, I'm going to get m squared, negative 2m, 3m, and negative 6. And then I need to add those m's together in the middle. And because I can see now that I have an m squared, I'm going to need to subtract that 24 over to the other side so that I equals 0. Because you cannot factor if your equation doesn't equal 0. Negative 2m plus 3m is 1m. And the negative 6 and the negative 24 add to negative 30. And the two numbers that multiply to negative 30 and add to 1 are positive 6 and negative 5. Now that I have it factored, m plus 6 equals 0 when m equals negative 6. And m minus 5 equals 0 when m equals 5. And those are my two answers. Double checking, m minus 2 was my only denominator with an m in it, and negative 6 minus 2 and 5 minus 2 don't equal 0, so I'm in the clear. I don't need to cross one of my answers out. Okay, continuing on. 7 times a minus 8 is 7a minus 56. 3 times 2a plus 1 is 6a plus 3. Then, because there is not an a squared, I'm going to subtract the a's to the same side. A minus 56 equals 3. Add the 56 to the other side. A equals 59. I don't have to factor, so I wanted everything on opposite sides. And there we have it. All right, we've finally arrived at our last example for notes. 3 times y plus 8 is 3y plus 24 equals y times y plus 5 is y squared plus 5y. Now, I tend to bring everything over to the side with y squared on it to make factoring easier. So I'm going to subtract the 3y and the 24 over to the right side, which leaves me with 0 equals y squared plus 2y, and 0 minus 24 is just going to be negative 24. And then I'm looking for two numbers that multiply to negative 24 and add to 2, which is positive 6, negative 4. So my answers are y equals negative 6 and 4. Y plus 5 was my only denominator. So negative 5 is the only answer that I couldn't have. And I didn't get that answer, so both of them are fine.